Hi everyone, welcome back to my channel. If you are new here, do not forget to like, subscribe and share. So today's video I'm going to explain leetcode 15 in an array, which is a three-sum problem. I'm going to use an optimal approach by solving a sorting plus two-pointer technique. Let's understand the problem. So the three-sum problem condition is like three things. First, you should add the three element from the array. Okay, that sum should be 0. Like from this example I can able to say -1, 0 and 1. It gives me the output sum as 0, right? So output as 0, and you should return the element. You should return the element. Okay, first condition is that. And another condition, the I should not equals to the j, and j is not equals to the k, and k I is not equals to the k. This means the I, j, k should not be pointing at the same position like this. I and j and k, this is invalid, and this is also invalid. Like I and j should not be pointing at the same position. And another condition is like the output element should not be same or duplicate. It should not be here. The unique elements are there: -1, -1, -2. Like another -1, -1 and 2 is not there. So this is should not be possible. If there, it is not possible. And here also there is an unique element like -1, 0 and 1. So I'm going to use these three condition, and I will apply two-pointer technique and for solving this problem. We already understand the problem statement and conditions. Let's apply this sorting and two-pointer technique. First I'm going to sort this array. Okay, like -4, -1, -1, -4, -1, -1, again the 0, again the 1 and 2. So this is sorted array of this array. So this is sorted array. Okay, first I'm going to sort the array. Next I'm going to place pointer. First I'm going to take it as I, because we want to add the three element, right? I'm going to take pointers. So j, and here probably k. At the end I'm going to take the k. So this is what the two-pointer technique look like. First I'm going to add these elements. Let's add these elements like -4, -1 and 2. So what will be the answer? -5 plus 2, it will be -3, right? It is less than the 0. So why we sorted means I will explain here. So if it is less than the 0, you want to move at the greater position, right? Here the arrays are arranged in a ascending order. If you go like this, it will increase, right? -4, -1, -1, 0, 1, 2. It is increasing. So if you go here, it will be increasing, right? Increasing. So if you increasing here, you want something greater, right? Like if I solve in a pointer approaches, like if I take like this, so -3 here, if you sort the array, you want the sum to be 0, right? Then you want to take another bigger number to become the 0, right? That's why I'm going to move the j pointer here. Again the j is same thing, -3 will come. It is again the smaller than the 0. You're going to move the j pointer so that it should become the 0. So now the j is pointing at the 0. Now j will become 0. Here the answer will be -4 plus 2. It will be -2. Again it's smaller than the 0. We will move the j pointer. If it is greater than the 0, we will move the kth pointer, because we want some lesser number to match the 0, like that. So j is now pointing at the 1 position, so it became 1. At here it will become like -1, right? -4 plus 3, it will be -1. Again it is smaller than 0. Here if j crosses the k, we are going to stop the loop, because we cannot able to take the k and j pointing at the same element. It is invalid condition what I send in a conditions. So let's solve using an here the I is at the index 0. Next I will move to the first index. For better clarity I did erased. So now the I is pointing at the first index. Okay, already we saw on the 0th index we did not got any answer. So we will check this first index condition. So now I is pointing at the first index, next the j is at the next, and k at the end. So -1, -1. I'm going to take these sums. Here we will get the answer like -2 plus 2 will be the 0 answer, right? So here we will getting the 0 as an answer. We will store it in a answer variable. Okay. Let's suppose this is temporary variable I am taking as for now. I'm going to store it in a temporary variable. So this will be my first answer. So first answer will be this. So I'm going to here you can able to move j also or k also. Both the here if we get the answer as 0, we will move the both pointer. Okay, because we would not want the same answers again and again. For that purpose we are going to move the both pointer, and we will check for this again -1 plus 0 plus 1. Here also we will get the answer as 0, right? -1 and +1 will get the answers, and we will get the answer as 0. Here -1 comma 0 comma 1, it is my second answer. So we are getting answer as 0. We want to move the both the pointer at the same time. So k is now pointing at this, and j is now. If we cross the j and k, here the condition comes like if the j is smaller than k, until that only you are going to loop it. If it crosses or pointing at the same position, we will not calculate that, we will end the loop. Okay. Then I going to move at the second index. Now I is pointing at the second index. Okay, and j will be the next element. Again k will be the at the last. So I'm going to calculate these elements -1 plus 0 plus 2. Here the answer will be the 1. So +1 is greater than 0, right? If it is greater than 0, carefully observe here, it is an important point. So if it is greater than the 0, I should move the kth pointer, right? I want here if I say -3, -2, -1, 0, 1, 2, 3, this is number sequences. If I get 1, I want some lesser number. I want to move here so that I can able to get 0. Here I will move the kth pointer. So now the k is 1. So here again we will get the same answer like -1, 0, 1. We would not store this. Okay, we will ignore the duplicates. Okay, again we will if we get the answer as 0, we will move the both pointer at the same time. So if they crosses or pointing at the same position, we will end up the loop. As I said, j should be smaller than the k, strictly not equals to also. Then next the I will be pointing at the third indexes. Now the I is pointing at the third index. Let me calculate that like 0, 1 and 2. So the sum will be +3. So if it is +3, it is greater than 0. We want to move the kth pointer. Okay. Now k is pointing at the same element. Here we would not calculate this element because it is pointing at the same element. So we will ignore this. Okay. So here the loop will be ended because if I move to this position, so the j is pointing at this. Again the k also is pointing at this position itself. We will cross here. and we will end up I, and again the I is pointing here, j is pointing here, and k is pointing here. So this will be not the condition we want, so we will ignore this all condition in a code. So this is what the end of the loop. Okay, we will get the two answers. We will return it to the output console, what is this in the output. So -1 -1 -2, so we get that -1 0 1, yeah, we get that also. So this is how you're going to solve this problem. We already solved this example. Let's solve this example. It's an easy one itself. So let me sort it. It is same element. We would not get any sorted order, right? So I, j, and it is k. So if we add this 0 plus 0 plus 0, eventually we will get 0. Here the answer will be 0, 0, and 0. Then we were going to move both pointers at the same time. So k pointing here, j is pointing here. Here we will end up the loop because j should be smaller than the k, right? If at the index j should be smaller and k should be larger. Then for better, I am going to erase here. So we get answer 0, 0, 0. For now, the I is pointing here, j is pointing at the next of the I, and k is at the end. Here we would not calculate because both the j and k is pointing at the same element. This is invalid condition. Then here also end up the loop, and I and j, I will come here. Again j is ahead of this. That's not the possible conditions. So at this point we will end up the loop. Just we will return the answer as an output console, which will be 0, 0, 0. So these two examples already over. So let's move to the next problem. So 0, 1, 1. Okay, though I is pointing here, and j is pointing here, and k is pointing here. Here I am going to add this like 0 plus 1 plus 1, it will be 2. If it is greater than 0, you want to move the k pointer. Here again the end of the loop, because you should not point at the same, or you should not cross. Yeah, then we are going to move the I pointer. Now I is pointing here. So this is also edge cases. We will eliminate this also because k and j is pointing at the same position. And again, if you move at the last, I is pointing at here. So here we will eliminate again k and I will be pointing at the same element. It should not be the case. So it is the end of the loop. At the end we would not get any elements, so we will return empty. So let's solve this in a leetcode. So let's solve this three sum problem in a leetcode. So this is 15th problem. It is a medium. So maybe it's an important interview question also. So given an integer array nums, return all the triplets nums I, nums j, nums k, such that I should not equal to j and I is not equal to k and j is not equal to k. What I explained here. So nums I plus nums j plus nums k should be equals to 0. So notice that the solution set must not contain the duplicate triplets. So I already explained this also. So I have taken similar examples and I did solve this and all thing. Let's code this up. First I am going to take array. For storing I am going to take array. Yeah, this is will be the linked list. I'm going to take it as a list. Okay, so this is a two-dimensional list. I'm going to take it. I probably take it as answer for better clarity, and new array list. So this is an array list, two-dimensional array list I created. Then I'm going to, first thing we are going to sort, right? So I'm going to sort using an arrays dot sort function. So I'm going to use the inbuilt function arrays dot sort function for sorting array. Probably let's take the n as length of the size. Nums dot length, it's a numerical length. Okay, then I'm going to loop it from 0 index to at the end index. Yeah, so first I'm going to write the conditions, like if I is not equal to 0, if it is not equal to 0 and nums of I is equal to nums I minus 1, because at the I equals to 0th condition, previous element will not be there, right? It would have taken garbage element and returned you something else, right? For that condition I return I is not equal to 0, and it should not be equal, right? It should not be equal. At this condition, what I'm going to do, I'm going to continue. So I'm going to continue the loop. So this will skip that particular part and it will run to the next. I should take j pointer. So j is pointing at the next index of I. Can I take it I plus 1? Yeah. So k is at the end itself, so n minus 1. So this what will be the j and k pointing at. So let me loop it from I to j and k. So the j should be smaller than the k. If you remember carefully or listen my lectures, so it should be the conditions. So sum, I'm going to take it I plus j plus whatever the k. I'm going to add it. Okay, if sum is smaller than 0, remember what I explained. If it is smaller than 0, we want some more number to be added, right? At that time, we are going to move the j pointer. Yeah, I am writing j plus plus. If you know, you just want to increment the j pointer, right? You can able to write like this also. Okay. Else if sum is greater than 0, what will be the condition? If it is greater than the 0, we want some lesser number to match up the 0, right? So that you will move the kth pointer to near indexes. You do k minus minus. Else it will be the answer as 0. We will store it in a temporary variable. First, we are going to store it in a temporary variable. We will not use an original array. Okay. Then we are going to add it in a original answer. Temp equals to arrays dot as list function. I am going to use this. Okay. This will add up the whatever fixed size of arrays as list. Okay. This is as list going to add up the fixed size of j and nums k. Yeah, like this I'm going to add up in a temporary variable. So and I'm going to add it in an answer so that I can able to get the new one and add it in a array, so that I would not get confused. So if we get equal to 0, that means we want to move the 2 pointer, right? After storing it, we will move the k and j pointer, and we will write one more condition, because it should not be equals, or it should not get caught up with the edge cases. For edge cases I am writing this. So if it's j smaller than k, what the condition is, and nums j is equal to nums j minus 1, it will end up taking duplicate element, right? At that time I can simply move the jth pointer. At that time I'm going to move the jth pointer simply, and again while j is smaller than k, and so k is equal to the nums of k minus k plus 1 here, because if it is previously, if it is equal, so no use of calculating again and again, right? So that I'm waiting this edge cases. At the end I'm going to return the answer. Okay, return the whatever the answer is there. So your return type also list and list integer, so I had taken here. So let's run this and see whether it is working fine or not. Yeah, it's accepted. Let's sum it up. So I can able to take say that it is taking nearly about big of n square, not exactly. It is taking nearly about big of n square time complexity, and space complexity is big of 1. So that's all for now.